Welcome back to D3, where we take a slow, deep breath before diving headfirst into the mysteries of our universe. Today, we're leaving Earth far behind and heading 390 million miles away to Europa, one of Jupiter's most intriguing moons, and one of the best places in our solar system to look for alien life. Tiny on the outside, massive in mystery, Europa is only a bit smaller than Earth's moon. But beneath its frozen shell is a vast, global ocean that could hold more water than all of Earth's oceans combined, and maybe, just maybe, the building blocks of life. We wouldn't even be talking about Europa like this if it weren't for NASA's Galileo spacecraft, which studied Jupiter and its moons from 1995 to 2003. Galileo measured strange magnetic patterns around Europa, ones that couldn't be explained unless something beneath the surface was conducting electricity. That something, a salty liquid ocean, and then there's the surface itself. Europa's crust is covered in a complex, crisscrossed network of cracks, ridges, and fault lines, but very few impact craters. That tells us something crucial. Europa's surface is young and active. Ice plates shift, move, and even reform like tectonic plates on Earth. Some scientists call it an icy shell over a living ocean. And then there's the chaos terrain. Jumbled, broken regions that look like blocks of ice have been shattered, shifted, and refrozen. That chaos may be happening because warmer, saltier ocean water is rising, melting the ice, and then refreezing into new patterns. It's like the moon is constantly rebuilding parts of its crust from the inside out. So how far down would you have to drill to reach Europa's ocean? Estimates vary, but most scientists agree the outer ice shell is somewhere between 15 to 25 kilometers thick. That's about 10 to 15 miles. Beneath that, a liquid ocean that could be as deep as 100 kilometers or more than 60 miles. For comparison, Earth's Mariana Trench, the deepest part of our oceans, is about 7 miles deep. So Europa's ocean could be 10 times deeper and spread across the entire moon. And it's not just liquid water, it's likely salty and stirred by tidal forces from Jupiter's immense gravity, which constantly squeezes and flexes the moon, generating heat from within. It's dark, it's deep, it's under pressure. And it may have been that way for billions of years. Let's talk about what could be happening at the bottom of that ocean, the ocean floor, far beneath the ice. On Earth, deep in our own oceans where no sunlight ever reaches, there are places called hydrothermal vents, volcanic-like openings where superheated water and minerals pour out of the seafloor. Despite the darkness, life thrives there: shrimp, tube worms, bacteria, and more, all surviving on chemical energy, not sunlight. Now imagine that same setup under Europa's ocean. Scientists believe Europa may have a rocky seafloor, heated by the same tidal forces that warm its ocean. If hydrothermal vents exist down there, and we have reason to believe they do, then we may have all the ingredients for life: liquid water, chemical energy, time, stability. This isn't just science fiction, it's a strong scientific possibility. We might not have to drill at all to find signs of life, because Europa might be spitting its secrets into space. In 2013, the Hubble Space Telescope detected what looked like plumes of water vapor erupting from Europa's south pole, like geysers shooting hundreds of kilometers into space. These plumes could be spraying samples of the ocean into space, where we could fly through them and collect material directly without ever touching the surface. Follow-up studies have found more hints of these plumes, though they're still not 100% confirmed. But if real, they're a game changer, an express elevator from the ocean to space. Meanwhile, surface features like reddish streaks and deposits suggest that minerals from the ocean are rising up through the ice, interacting with radiation from Jupiter and getting baked into visible patterns. Europa isn't quiet, it's active, and it's talking. To really understand what's going on, we need better data. That's where NASA's Europa Clipper comes in. It launched on the 14th of October 2024, expected to arrive Jupiter around 2030. Europa Clipper will make dozens of close flybys of Europa, use ice-penetrating radar to map the ice shell, analyze surface composition and magnetic fields, hunt for plumes and potential landing sites. It won't land. It's not a life detection mission yet, but it will lay the foundation for the first human tools to go beneath the ice. If all goes well, Clipper could be followed by a lander mission in the 2030s or 2040s. And that's when things get truly historic. Europa has all the essential ingredients for life as we know it. Liquid water, energy sources, organic chemistry. A stable environment that's lasted billions of years. If life exists anywhere beyond Earth, Europa is one of the most likely places to find it. It might not be intelligent life, but even a single-celled organism would be one of the greatest discoveries in human history because it would prove life isn't rare, it's cosmic. Europa looks like a frozen marble in space, but beneath its shell could be a deep, alien ocean world teeming with secrets. Maybe even life. Maybe the kind we've never seen before. And we're on our way to find out. So if you're as fascinated by this icy moon as we are, don't forget to subscribe and help us reach 3K by June. We're just getting started. And always keep looking up.